Right. All right, everybody. Welcome to another meeting, online meetup of Pacific Hackers. It's a continuation of today's Percent 27 meetings. We had two presentations already on the East Coast for Hack Miami. Then right now we're gonna have two presentations. One with Alex about content security, and myself on the second hour about attacking and defending drones. Um, Before we get in, um, let's do a little housework. First, the meetings will continue until it's safe to go back. Right now, in my reference, which is Florida, as of Monday, most of the stuff was opening. As of next week, nightclubs, gyms, and even martial arts style type of businesses will be open. So down here, they're looking at around August for return to in-person meetings. I know California is a little different. We are looking at the California situation. I know that Santa Clara just relaxed their restrictions, and so we will be paying attention to it. I'm in constant contact with Marco. Marco is also monitoring the situation, and when it's safe to go back, we will announce basically to our in-person meetings. I would say that conservatively speaking, we're probably looking at August. That's what I think. The provided that you guys will know, because in California, you're a little behind here. They're ahead in Florida. So if people are gonna start dropping dead left and right, it will happen here first. So hopefully that will not be the case. But we're certainly looking at August for the return to in-person meetings. We'll see how that goes. We may do some hybrids where there's some people in person and then some people online. We still have to see with the situation with the airlines. It's also very confusing at this point. So it's again, it's a very confusing situation, and every area, even the CDC doesn't seem to have a consistent message. That's why I invite you to join Slack, and we have a channel. The channel is called Current Disaster, and that channel we have been very accurate about things that had happened, and which we sort of made our own mindset of how to deal with this. So please, in order to keep connected, it's important that you join the Slack and participate. We have now a new, I guess, mean of communicating. We are testing a Discord Percent 27 channel. So we're going to run Discord in parallel. And when the members feel comfortable, then we might do the switch. We don't know yet. But I want to give enough time for everybody to feel comfortable and say, okay, I'm ready to go to Discord. We are out of Keybase. We used to have a Keybase backup. We got out of it. So we're testing Discord. If you go to the Slack channels right now, you will find the invites. Everybody, it seems to be, the hacker community seems to be embracing Discord. If you guys attended the Red Team Village Summit last week, it was pretty amazing. And it was I would say a sample of how DEF CON, virtual DEF CON would be. As we all know, DEF CON, there will not be DEF CON in person, and that sucks. But there are some efforts to do some villages, specifically the Red Team Village. I wrote the redteamvillage.com or .io address so you guys can go and check it out. They did an amazing job, and they're preparing a lot of cool stuff for during the DEF CON time, CTFs, kinds of trainings. So you guys want to check it out, you can still volunteer as well. So please check that out. There's also some information about the Blue Team. As soon as I get the Blue Team village information, I will post it. Any village that I get information from, I will definitely post here, because we do want to keep the community alive, even though we're not going to be able to meet this year in Vegas, which sucks. There is, by the way, there's a chatter of an in-person con, unofficial. I don't know. There's a group of people, and I keep hearing about it. I don't know if that's going to happen or not, but definitely I know that there's a group of people that are going to go there, and they're going to do DEF CON, unofficial, I guess, because the official one's canceled. So we'll see if that happens. I'm not going, and most of us don't believe that it's still safe enough to or clear enough to know what to do. That's possibly the biggest problem. The data is not clear, and we don't have enough information to make a rational decision. So we will still be looking at the information that's coming in and make a decision based on that. But as far as us, we're going to continue online. And again, we're looking at August for probably the restart of the in-person meetings, providing, something bad happens or there is an increase in cases and rates of death, which is usually what I look at, hospitalizations and rates of death. Layoffs are hitting the industry. That is worrisome. Some of us have been affected by either change of compensation, or some people have been reduced hours, and some others have been let go. This is, we just saw a news from IBM that is worrisome, because usually what happens is when they see a big company like IBM, for example, most likely others will follow suit. So please stay alert and communicate. There is a job offers channel where we have plenty of offers. If you are looking for a job, if you were affected by this, we do have a job offers channel where I post everything. Everybody posts everything, including people that are hiring internally that may not publish or that may not use recruiters. We're still using this channel to help everybody that has been affected. So please stay in touch. It's important to figure out where this is going, because it seems like I see the number of layoffs growing, and I see the number of companies new every week, and that's definitely worrisome. Again, we have a new Discord channel. We're sort of doing back and forth with it. Right now we're playing the hack and sack competition. There's some people that are engaged. You can actually play it or go there whenever you feel like after the meetings. I was there until late yesterday. There will probably be people overnight playing this game. Some of the challenges are pretty cool, so I invite you to join us and help us. Other than that, these meetings are going to be recorded, and they will be in the YouTube channel. And again, if you want an invite for our Slack, and once you're in Slack, you'll get the information for Discord. Just email me, and I'll just send you an invite. So with that in mind, I'm gonna introduce Alex, which is gonna talk to us about container security. So he is part of our Pacific Hackers in California, and I had the actual opportunity to see his presentation. It looks pretty awesome, and I'm sure he's got a lot of great stuff to talk about today. So without further ado, this is Mr. Alevsky.
Okay, thank you very much, Rod. Okay, let me share my screen.
Quick question, Alex. Do you want people just to post questions on the chat and you read them, or do you want some of us to people interrupt you and ask the questions?
Yeah, I think whatever option is fine. Yeah, if you have a question, please ask, and yeah, we can discuss it. Yes.
Yeah, or do you want to have like a Q&A session at the end and going back to all the questions?
I think we can have a Q&A section at the end, because I think I have like 45 slides, so I don't want to extend more than an hour, so I don't want to steal time from Rod as well. So maybe we can have a short Q&A at the end.
Okay, so yeah, so for people who ask questions, if you can put a Q in front of the question, so we can, basically separate between comments and questions. So you know, if there's a queue, automatically we know that's a question. So if not, you know, we're still gonna read everything. So anyways, go ahead, Lux. And
Okay, cool. Can you see my screen now?
no, not yet. It's coming.
Okay, I just share my screen and put the presentation mode. I'm sharing. It's not showing.
Yep.
Okay, let me try again.
It's starting to share content, so maybe stop and start again.
Okay. Going to try again. Trying again. I'm sharing only that Chrome window. Can you see it now, or?
No, same message.
Negative.
Okay, I think what's going on, maybe it's my screen is like a 5K, so let me try to very quickly use only my laptop.
Yeah, probably share the whole screen.
Yeah, the whole. 1 second.
And also for the people who are not asking a question or anything, please go ahead and mute yourselves.
Can see it now.
Okay. Okay, but my screen is all dark, so I think for me it's coming up. Okay. You can see it now?
Yeah.
See you and the presentation now.
Yep.
Okay, cool. Let me move the window here. Go into presentation mode and let me pull my notes. Okay.
Good, I think.
Okay. Can you see only the screen or also my notes?
Your notes as well.
Okay, let's do Rambo without notes. Okay, so I'm going to talk about container security. This is a presentation for Pacific Hackers Meetup, and I'm going to go ahead and introduce myself. My name is Len Alevsky. I'm from Mexico. I'm not Russian or communist, but you still call me comrade if you want. And I'm a security software engineer. I live here in the Bay Area, and I have a crazy obsession with security. Like literally, I love every aspect of security. So yeah, I'm going to start. I'm going to talk about container security, but first, I would like to talk a little bit about history, like how historically developers and DevOps people has run application over the last 10, 20 years. And we can see like three main architectures, right? We start with the traditional architecture, which is we start with the hardware and we install an operating system and we put applications there. And whenever we want to run more applications isolated between them, it was as easy as bringing more hardware. But then everybody start asking about software, right? And this start to become a problem because usually people start running out of hardware. So then the virtual machine architecture start to come into the play. And now a single piece of hardware was able to support many customers, right? Many virtual machines, and the applications were isolated. And this model works very well for a time, but then it starts to become a little bit messy because once you want to update your application, usually you want to update your libraries and dependencies, and those dependencies were tied to the underlying operating system. So a single change in your application could end in the whole update of the VM. Also, another problem we seen in the past is moving around those VMs between machines. It was a problem because virtual machines were very heavy. Like we're talking about like hundreds of gigabytes, right? And it was very slow. So Then the container application, the container architecture come into this place. And it was a new paradigm of how to run applications. Now, instead of an hypervisor, you have a container engine, and you only have in top of that your application and libraries. So you end with small pieces of software that you can transport between other container engines, right, or other pieces of hardware. So this started to become very popular. Also became very popular among attackers, right? And we are going to talk about the offensive and defensive side of those technologies. So we start with this question, right? Like, what are containers? Usually when we hear the word container, we immediately think about Docker because it's the more popular, right? But in reality, there is way more options. Like there is Linux container, there is Elixir, there is Elixir, and there is Rocket. I'm going to talk mostly about Docker because it's like the most popular, and most of my examples are about Docker. But answering the question, like if you go into Google, you will find that Docker is a technology that allows you to pack your application and dependencies in a single deployment vector, right? So you can move those applications between container engines, and everybody's happy. But what if I tell you that that's a lie? Like everything is a lie, right? Like in reality, there is no container. It's just another process running in your machine. And I'm going to explain why. So what containers really are, right? Like usually in your operating system, when you open programs, those programs exist in the way of processes. And those processes belongs to groups and are surrounded by namespace, right? Like you can define some rules to tell this process can only talk with this one, and the processes are going to ask the operating system about resources, but they cannot grab those resources directly. For that, they need to talk to the kernel via system calls. And for doing all these things, of course, this is an oversimplified diagram, but for do all these things, there is three main mechanisms that the operating system use, which are the namespaces, the C groups or control groups, and the capabilities. So I'm going to talk a little bit more about those three that give you, like, made your operating system work, right? So namespaces, like you can summarize this like is essentially what your process can see. And by default, Docker uses 6 namespaces. Like the first one is UTC, meaning user Unix time sharing system, which allows you to, well, if you have run the Docker run command in the past and then you exec or go inside that container, you will notice that the name of that container is like something like an auto-generated name, right? If you're wondering how is that possible, that is because of the UTS namespace. Like allow you to define like a different name of a name different than the host machine. Another one is the PID or process ID, right? This allows you to do a process isolation, and this reads directly from the /proc folder, right? So this is why if you leave the process inside a container, those processes are going to be different than in the host machine because they essentially have different proc folder. Then we have the IPC, which means inter-process communication, and this essentially helps you to achieve the process isolation. So processes inside a container cannot talk directly to processes running outside the container, like in the real machine. Then we have the network, which achieves isolation at the network interface level. We have user that allow you to have different users from inside the container and outside the container. So usually when you run a Docker container, you will notice that you are root inside that container, right? But that doesn't mean that root user is the root of the host machine. So this is achievable via the user namespace. And finally, we have the mount namespace that help you to achieve isolation at the file system level, right? So as I said before, if you do the Docker command and then you run like this image, this MinIO image, and you go inside that container and do the list processes, list network connections, and then list files, you will see a very different output that if you run those commands in the host machine, right? Like containers, they only see what the operating system want them to see, like, but they are like any other processes, and most of the application running inside container doesn't know they are inside a container. Next one is the C groups, right? As I told before, like C groups is a mechanism for applying limitations to resources of the processes, right? This is how you can achieve telling a container that you should not use more than 50% of the CPU, or you should not use more than 5 gigabytes of RAM, right? Like all that can be achievable using C groups, and this is very transparent for the software, right? Because application developers should not concern about all these limitations. So you put these limitations in place from outside the application, like we have in the container. And finally, we have the capabilities, right? Which is the last piece of the puzzle. So historically, before kernel 2.2, I guess, there were only two distinctions in Linux, the normal user and the super user. Like if you are the super user, you can do everything in the system. You can destroy the whole system, right? And that was a little bit of a problem, because if I have a small application that need only to run a service on a privileged port, I need to give the whole super user power to that application. And if that application is compromised, that became a problem, right? So after that, capability concept was created, and this is essentially like they are splitting the whole super user power into several units, and each one of those units allow you to do a specific operation in the operating system. Like for example, here the most popular, we have net route that allow you to communicate to the network, create packages, set UID, set peak capability, shown. So there is, here I'm showing 38 capabilities, but I think in modern Linux operating system, there is more than 40 capabilities. And each one of these allow you to do one action in the operating system. So, okay, enough about the theory. Let's talk a little bit about the offensive security part of the containers. So we're going to talk about like how to abuse those three mechanisms that we mentioned before. So in this first example, imagine that you are the root of the root user of a system, right? Like all the commands on the right of the orange square are running by the root, and you as a root user has a secret file that contains like some secret information. Like you create the file, you can list the file, obviously, because there is another user in the system, all the commands that are on the right of the yellow square, that is trying to see what is inside that file, but naturally he cannot do that because he don't have permission. But if for any reason that user has access to the Docker command and can run it, like what he can do is he can run a new container mounting the home folder of the root user, and then go inside that container and list the secret file, which is everything that is happening on the right of the blue square, right? And why is it happening? Because in Linux, like every user that has access to the Docker command is essentially can become like root of the system, right? Because of the way Docker works, the level of privilege that binary needs. So this is the container breakout by volume example. And host network breakout of host network is very similar, right? You can run a Docker container using the privilege flag and then using the net and the net namespace and passing the to be equal to host. And if you exec into the container and then run the netstat command, you will see all everything that is running in the host machine from the network perspective, right? And also the same is true for the process IDs, right? If you do the same, but this time you use PID namespace, process ID namespace, and you say equal to host, and then you list all the processes inside the container. You will see all the processes running in the machine. And I have another example here, which is called the container escape part 1. So in the previous example, you can say, but hey, Alevsky, that's not fair. You already have access to the operating system, right? Like, and I'm going to say, yeah, that's true, but there is also possible to escape from inside a container, right? Like previously we have already access to the host machine. Now we are inside a container, and our goal is to escape from that container. And in order to do that we're inside a container, for some reason, there is this special file marked as pink mounted inside a container, right? So this is the Docker sock file, and it's essentially a Docker socket used by the Docker daemon. And if for any reason that is exposed inside the machine, inside the container, sorry, what we can do is download the Docker binary. Here I'm downloading the Docker binary, and then we can run a Docker commands, right? So here what I'm doing is on the right, I'm listing all the files and folder of the proc/proc folder to demonstrate that this container has access only to the processes of inside the container, and then I'm running a Docker command that is saying Docker run mount/proc to /proc fs and run this new container in privilege mode. So here, a very important question is which proc folder you think is going to be mounted, the proc folder of the mini container or the proc folder of the host machine, right? The answer is the proc folder of the host machine, because this command is going to be executed by the Docker daemon. And what is going to happen there is if we exec into this new container and then we list /proc fs, we're going to see way more processes that indeed these are the processes of the host machine. So this is not enough to escape the container, right? We need to change the namespace. So right now we just break volume isolation. We need to break user isolation and all the other namespaces. So in order to do that, we can go to procfs/1/ns. And this is very important because in Linux, like the initial process ID is the ID1, and this is the initd process, right? So inside this folder, we're going to see all the different namespaces, and we can use the nsenter command to essentially, as the name says, enter those namespaces. So here I'm telling nsenter to switch my IPC namespace, my mount namespace, UTS namespace, and network namespace. So once I do that, I go into that namespace and I can start like typing some commands as I am in the host machine, right? Which is everything that is on the right of the yellow square. So I do ls, I do docker ps, and I'm essentially escape the container, right? I effectively escape the container. So this was a container escape part 2. And if you think like nobody is so silly to mount the Docker sock, I'm very afraid to tell you that's not true. If you go to the Docker, to GitHub, search and search for Docker sock, you will see like almost 300,000 reference to that Docker socket, right? And it's not completely a crazy idea. There is a lot of projects that need this Docker socket, like projects like Jenkins that did need to spin up container dynamically. So they need that, right? The only thing is that if you do this, yeah, you need to create your software in a different way that cannot be compromised that easily, because if someone compromise a container that has access to this socket, like everything is game over, right? They can take over the whole infrastructure. Okay, that's enough for the offensive part. Now I'm going to talk about a little bit the defensive security, how to protect your containers, how to make it more secure. And there is essentially 2 ways to do that, right? Like like protecting your images and containers and at runtime. So I'm going to start about how to create scratch containers when less is more. So I have this small example of a Go program that is called main. So this main program is going to start a basic service that exposes a slash run endpoint, and this endpoint will receive only two parameters, command and message. And this is a very, this program has a vulnerability called command injection because essentially allow an attacker to pass whatever command he wants. And this program works with another program called encode. So the main idea is that the main program is going to call this binary, and a user can pass a message and is going to receive the output of the encoded version of that message. And if you deploy, the next step is to deploy that using containers, right? Docker. So this is the syntax of how to create a basic container. You can create containers using the Docker file. And the first thing I'm doing here is I'm installing all the dependencies, and then I'm statically compiling the binaries, the two binaries, and then I'm telling with the cmd directive that whenever this container starts, it's going to execute the main binary, right? So the syntax to build containers is the one that is in the bottom, and then we run that container, right? We're exposing the port into the real port of the host machine. So you can type localhost/1337 in your browser, and the resulting image size of this for this container is going to be almost 900 megabytes. So once your container is running, if you go to your browser, in the first example, you will see that the program is working as expected, right? I'm saying command encode, and then I'm passing a hello world message, and I'm getting the base64 output. But then what about if a malicious user pass the cat command and then the etc password? Like you just got pound, right? And the developers could argue that this is not a bug or a vulnerability, it's a feature because the software is working as intended, and they don't want to be limited. They just want to keep adding more and more binaries into the container without changing the underlying code, right? So they will not fix the code, but we can do that. The way we can do that is using what is called a scratch image. A scratch image is essentially an empty image. So once you do all the compilation and the dependency download of your application, then you essentially will copy only the binaries that you care about, which are the encode binary and the main binary, into the scratch image. And then we are saying that whenever this new image starts, we are going to run the main command. The result is going to be a way less image. It's only 3.19 megabytes because we are ignoring everything that doesn't have to do with our application, right? So if we do the example again, and the functionality is still there, is working as intended, but now if an attacker wants to execute the cat command, it will not work, and he will receive an error that says the cat is not found, right? Because this container only has the main binary and the encode binary. And we can tell that is true because if we also want to go inside that container via the docker exec command, we will not be able to do that because there is no bash binary, right? So this is a very effective way to have only what we care about and ignore everything that we don't care about and reduce the attack surface on this container. So in this example, it was very easy because I was using Go, and we can create like statically linking binaries. But what if you are using other programming languages, like interpreted languages like Python? Well, it is possible to do with Scratch containers, but you will have to consider some other, like copying the interpreter and all the dependencies, right? But fortunately, there is this distroless project, which is part of the Google Container Tools. And these guys already have like pre-built images for most of the popular programming languages. Like if you want to do Java or Python or Ruby, they have already versions ready for working with those language, and will contain only the important tools and dependencies. Like they will not contain like a lot of operating system stuff that you don't need. So if I do the distroless image this time, the image is going to be a little bit bigger because it's not a Scratch container, but this image will not contain anything that can be abused, right? Like the cat command. So this is another way for you to create like more secure images. Takeaway for this section is most Docker images by default include lots of necessary binaries, right? And those binaries often can be used to escalate privilege that as we shown. And the main idea is to build minimal containers to reduce the attack surface. Okay, and now I'm going to talk about runtime protection, right? Like we already know how to create secure images, secure containers. What about if the application is already deployed, and how to mitigate the attacks, right? So in general, there is 4 ways to do that via capabilities, SecCom, which is short for secure computing, AppArmor, which is short for application armor, and CE Linux, which is short for Secure Enhanced Linux. I'm going to talk a little bit about the 3 ones, and then your task, your homework is to investigate more about CE Linux. So Linux capabilities, like Docker command allow you to manage capability basically using 4 flags, which has capability add and capability drop, allow you to, as the name says, add and drop capabilities, right? So you can add whatever you want of the list that I showed you before, and your application is going to behave in different ways, right? It may be gain functionality or it may lose functionality. Then if you want, by default in Docker, the containers run in unprivileged mode. That means they doesn't have access to the device of the operating system. If you pass the privilege flag, then your container will have access to all the devices. And if you don't want that, you can use only the device flag and specifically say which device do you want to have. So by default, Docker will assign these capabilities to your container. So everything that is here is going to be accessible for your container.
왜? 여기 있어야 되나? 아니야. 이거 왜 이렇게 왔어? 이거 사업 저기 따가져 왔대.
Make sure some background noise.
몸에 좋으니까.
Please mute yourself,
뭘 사고?
guys.
코스코 가기도? 왜 가, 코스코야? 뭐 아무거나 사와. 소세지 같은 거 사면.
Got it.
Okay, cool. Thank you. Okay, so Linux capabilities. So in this example, I'm running a very basic Alpine container. And if I go inside that container and do the ping command, I get connectivity, right? And then if I run again this container, but this time I say drop the network route capability, and I try the ping command again, I'm going to get permission denied, because essentially the processes inside that container are not allowed to create route packages, right? So you can apply the same principle to any other capability. And the next one is secure computing, right? So this is secure computing is another security mechanism for Linux that allow you to filter at the syscall level. That for now, by default, Docker will block 44 out of the more than 300 syscalls that exist in the Linux kernel. And blocking syscall have way more implications. So the way to do this is you can define all these policies via JSON format, and you can tell to block the syscall or to throw an error or to drop. So if you like, you can take a look about this file. This file is the default seccom profile, and you can see like all the policies that exist here. So in this example, like going back to our previous example about the vulnerable endpoint. So and in the top, I'm running the container without the second profile, and an attacker is this time the attacker tries to create a folder on the slash temporary folder, right? So he's creating the pound folder. So he send the request. He don't get any error, and if we exec or go inside that container, we're going to see that the folder was created correctly. But on the bottom, like if we create this secure computing policy and tell, hey, processes inside this container are not allowed to create folders, and then we run the container using that policy, and the attacker tries to do the same, he's going to get an error this time because the process inside the container is not allowed to do that. And we can check if that's true if we exec into the container and leave the folders inside them, right? We will not see anything. So you can be asking right now, like, okay, like why just block like making directories? Why not block like reading files or even like cloning processes, which is another important system cause? Well, because blocking syscalls is not that simple, right? As I say before, like blocking a syscall can have like be a lot of implications, right? Like the way this thing works is like when you decide to block a syscall, you are not blocking the syscall only for a particular application. You are blocking the syscall for all the applications or processes inside a container. If we try, for example, to block the clone syscall that is being used, like for example, when we try to change namespaces with the nsenter command, our container will not even start, right? We're going to get an error at the beginning. And then if we want to block the read syscall for an attacker not to be able to read what is inside etc/password, again, the container will not even start because all these syscalls are needed not only for our application, like for the whole container lifecycle itself. So if you want, I mean, very interesting thing to do with containers, but it requires a lot of effort. And if you're willing to go through all that suffering and still want to learn more about Syscall and secure computing, be my guest. And there is ways to do that, right? There is the way to do that is using specialized tools like strace, dtrace, and dtrust to do that, right? So I'm not going to talk a little bit, I'm not going to talk about this tool because they are very specialized tools, but you can investigate more about those. And I think finally, the last way to protect running containers is using AppArmor or Application Armor, which is like a more easy way to do that. Like instead of blocking like one syscall for the whole container, Application Armor allow you to block many different aspects of the container. Like you can block capabilities, syscalls, or execution of particular binaries. You can be like more at the more granular level, right? And you can also define apply this policy only to this process running inside the container. Like in this example, this is a AppArmor profile for the Nginx reverse proxy software, right? Here we are telling Nginx to block deny, the reading of etc groups, right? Or deny the reading and writing of the run nginx PID file, right? So you can be very specific and you can block or allow only what you need. And this is very useful. So, okay, I have one last example, which is how to mitigate the same vulnerability, but now using only Application Armor. And we start by creating this small profile. In AppArmor, everything is about profiles. The way it works is that you start defining your rules. In this case, I'm going to deny all the reading and writing and execution, and I think link is hard links for these two files, etc password and etc shadow. And then what I need to do is run the AppArmor parser. This command essentially is going to load that AppArmor profile into the kernel, so it can be used by all the other applications. And then once the profile is loading to the kernel, I can use the security option flag for Docker and pass the AppArmor profile. And next time the attacker tries to do the same thing about cat command, which is almost in the bottom, he's going to get a message, an error message, right? Because there is a policy in place for that container to don't be able to read the etc password, and cat use the etc. Cat use the read, as it's called, right? And also is reading the specific file that we are blocking. So AppArmor is a more easy to use tool, but still there is a lot of configuration and a lot of things that we need to learn. So there is a lot of work around AppArmor, and specifically there is this tool that is the one I like the most, that is called Bane, which is essentially a best AppArmor, right? You can define like the rules and policies in a more friendly way. Like you can say things like deny exec or allow capabilities or allow these network interfaces, and you can write all of this in a more friendly format, right? Like I think this is TOML format, so you can download Bane and play around and essentially write like better AppArmor profiles. And we are reaching the last part of the presentation, which are the container tools. So if you are more interested about what tools are there for improving the security of your containers, or even doing like pen testing of the containers, I have a list here. I'm not going to talk about all of them, but I can tell you, like, if you want like a Docker's, like a vulnerability scanner for your container, you can use Docker scan or Clear scan, right? Also, if you want to run Docker in rootless mode, there is this project from Docker itself, which is an experimental mode that you should take a look. It's called rootless. We also have Docker Slim that allows you to create more slim containers automatically without you trying to worry about like which binaries to copy only. We also have some tools for the policy and compliance guys, which is AuditD and DACDA. These tools are going to go and check for some basic security best practices of your container images and containers already running in production. And we have also Docker Bench, which is like a framework for container exploitation. So in summary, like container security is mostly based about security that already exists in Linux, right? So it leverages on that. You should be running your containers as you don't trust them, right? You don't trust the applications that are inside those containers. You should be implementing secure compute, doing whitelisting for the system calls, and also implementing application armor, doing whitelist as well. Drop all the Linux capabilities that you don't use. And I think I didn't mention that, but also please root your containers as normal users, right? There is a user flag in Docker that allows you to define like you can put whatever you want, like a user and group, and then the application inside that container will not be root, right? So if you want to learn more about how containers work, like in the internals, there is I put here a list of resources that I use or that I have been reading and using over the last 6 months, like from internals to a high-level application tool that allow you to create more secure containers. So you should take a look at this. And I think that will be everything from my side. If you want to be in contact with me to ask me more questions about containers, or if you want to ask me security related stuff, I can be reachable on Twitter and on LinkedIn. You can drop me an email. And I also enjoy playing CTF. If you want a member for your CTF team, you can contact me. And I think that will be everything from my side, Rod.
Thank you very much. That was an amazing presentation. Do we want to go over the questions now?
The
have a
Q&A.
question. Yeah. There's one here. Let's see. It says there's one that says if docker.suck is somehow disabled, will the breakout be still possible?
If Docker inside the container,
I'm assuming so.
the thing is, if the Docker socket can receive commands, those commands are going to be executed by the Docker daemon. So yeah, if it's exposed inside the container, like they can cause a lot of damage, right? I was hearing this question the other day, like, what can you do, like, in the case your container need the Docker sock inside there? The way to fix that is, or the approach to do that is try to do the Docker daemon in rootless mode, right? Which is experimental feature, but that's the only thing you can do for now, I think.
Okay. Here's another question. Is
I can see that.
the drone is coming next, Mara. We're on the questions for
Okay. I was just wondering. I thought maybe I missed something. Thank you.
let's see where we are. Okay, is a seccomp profile is supplied on the command line? Does this profile is on top of default seccomp profile used by a Docker? Or used by Docker, one that blocks 44 system calls. I guess that's what he assumes.
Let me look for if second profile is supplied on the command line. So the profile is on top of default second profile used by Docker. No, I think the second profile that you specify is going to affect all the processes inside. Like it's going to replace by default whenever you run a Docker container, it's going to have a default second profile. So if you define your own second profile, it's going to override whatever Docker provide by default. And so it's possible for you to completely eliminate the default second profile, right? And I think that configure. So yeah, in summary, if you define your own second policies, they will override whatever Docker provide by default.
Okay, there's another question. Is App Armor only available on particular distributions of Linux? I believe so, right?
I think it's App Armor is and second are like very old Linux features. So I have used it only Application Armor on Ubuntu, but I think they should be available in all the other popular distribution, like mostly for Linux server, like CentOS. I think it should be there. Don't trust me on that. Like I need to check that.
Okay, here's another question. How does Docker's security requirements compare to Red Hat's rewrite, parenthesis, Podman?
Which one is that question? How does Docker security requirement compare to Red Hat? I have no idea what is Podman. Yeah, I need to investigate more about that question.
No problem. Any other questions? All right. Well, we'd like to thank you, Levski. That was an amazing presentation. Thank you very much. This presentation will be published soon tonight in the YouTube channel for Pacific Hackers. And remember, because we don't have over 100 subscribers yet, we can have like our own URI string. So at this point, you got to go to YouTube and search for Pacific Hackers. I think that there's another question. Did App Armor start on SUSE? I guess Linux SUSE. I think that he responded to that question previously.
Yeah, I think he's asking if it was created on SUSE. Yeah, I'm wondering. Like I know AppArmor is a very old project, also very old, like secure computing. So yeah, maybe maybe it's that old, like SUSE old.
All right, let's. All right. Let me do this pretty quick, and thank you very much. and we're going
Thank you very much, Rod. If you have more questions, guys, you can send me a DM on Twitter and everything. And thank you very much for the chance to speak about Docker container security. Let me stop sharing.